I'm just going to take you through a couple of examples right now of writing ionic formulas, because I figure that's one that we're struggling with. So, first thing we always do, take your name, okay, and write down what the chemical symbol is going to be based on your name. So we know aluminum is going to be Al, and nitride, okay, this right here is really nitrogen. Okay, so what we're going to do next is we're going to look on the periodic table, okay, and we're going to find aluminum, okay, and looking at our periodic table, we see aluminum is over here in group 13. So if you're looking, see that 3A at the top? That's telling you that aluminum has a +3 charge. Okay, because we know aluminum's a metal, so that means it's going to be positive. Okay, and we're going to find nitrogen up here. Okay, it's up here in group 15. Okay, it's going to have a -3 charge. Okay, because here is our group 18. They have the full shell, so it needs 1, 2, 3 electrons to have that full valence shell. So now what we're going to do is we're just going to bring our chemical symbols down. So we got aluminum, and we're going to put them right next to each other. We got nitrogen. And so generally what we do is we take the charge from nitrogen and we take the charge from aluminum, and we figure out how many do we need to balance these out. So our compound, okay, has a neutral charge. So if we have +3 from aluminum and -3 from nitrogen, okay, they already cancel out. +3 minus 3 gives us 0. Okay, so we only need 1 aluminum to balance out that 1 nitrogen. So this right here, that's going to be our chemical formula. And we're done. Okay, so we're going to try one that's a little bit harder now. Okay, so down here we've got iron. So we know iron is Fe. Remember that when we have a transition metal, this right here tells you what the charge is. Okay, because if we look at our periodic table, okay, iron's going to be right here. We don't know. This block can form many different ions. Okay, so that's why we need those Roman numerals to tell us what's going on. So iron's +3. And then we have sulfide. Okay, sulfide is really sulfur. Remember, we changed the ending, okay, so that UR became that IDE. So we're just going to write down an S. Okay, so now we need to, again, look at this periodic table. We got sulfur right here. It's 1, 2 away from our noble gases, so that full valence shell. So it needs 2 electrons. It has a -2 charge. So if we're looking at this one, we can already tell it's not like the one we did up here. We have an unbalanced charge. So what we're going to do, we're going to rewrite it. Okay. So we know we have iron. We know it's bonded to sulfur. But now we need to figure out how we're going to balance these out. Okay, so the way I like to think about this, okay, is this just basic multiplication. So if we have 3 iron, +3 from iron, and we have a -2 from sulfur, okay, 6 is going to be the closest number that both of them will equal to. So in this one, we're really doing 2 times 3 equals 6. Okay, so the way we're going to get this to balance out in the charge, we know we need 2 irons to get to 6 as our charge. Okay, so we're going to come over here to iron and we're going to put a 2. When we're looking at sulfur, we know it has a -2 charge, so we need 3 of them to balance out my ions, okay? So this is going to become a 3. So I want you to notice, okay? It's like they just switched numbers, okay? We know that we need 2 times 3 to get 6, and we know we need 3 times 2 to get 6. So both of these have the same charge and will cancel each other out. So this is going to be our formula. Okay, so now we're going to do one that's a little trickier, only because it has this polyatomic ion. So if you notice, the other two ended in IDE. That tells you it's just a normal atom, okay, of an element. This group ends in ATE. That's telling me this is a group of elements that's acting like one thing. So first thing we're going to do, just like before, we're going to write down our chemical symbol. So there's strontium, and we're going to look at our polyatomic ion chart, and we're going to realize that phosphate is PO4, and if you look at your chart, it should tell you what the charge is. So we know that we have a -3 charge, okay? Strontium, we're just going to come onto the periodic table. We're going to find strontium. It's right here in group 2. So that means that it has a +2 charge. Okay, and just like we did before, we're going to do it again. Okay, we're going to write it down. So strontium, phosphate, and then we're coming back to these charges. Okay, so how can we get 2 and 3 to balance out to be a neutral charge? Just like we did up here. This time we have 2. We're going to multiply it by 3, and that will give us 6. Over here, we're going to take 3, we're going to multiply it by 2, and that will give us 6. Okay, so in order to balance out our charges on our whole compound, we need 3 strontium. Let me use the right color. 3 strontium. Okay. And we are going to need 2 phosphates. So I want you to notice something. If I put that 2 right there, what's this big old mess look like? That looks like I have 42 oxygens. That's no bueno. Okay. So we are going to put our group in parentheses. So when you see this, this is saying we have 2 of this entire thing. And we know that phosphate has a -3 charge. So there we go. There's our -6. Strontium has a +2 charge. So this is our +6. So overall, we have 0 as our charge, and this is our formula. All right, guys, quick overview. Keep in mind, you can always come visit me during tutorial time and we can practice a little bit more.